Welcome back to proof number 2. Here I'm going to do a set containment proof, and this is actually standard operating procedures of how to do a set containment proof. So there's some things that you learn in class that are used for every case. Like if I ever have to show set containment, this is the procedure to how to do that. So I'm supposed to prove that A intersect B is always contained in A union B. First step is that you have to believe it. And the way we test things out for sets is we draw something called the Venn diagram. So in your book, they talk about Venn diagrams. The concept's pretty simple. You draw a set A as a circle, as a diagram of the set A, and B is a circle of the diagram of set B. And in this case, A intersect B would be the region that is shared by both. So it's this football region in the center, and it's blue. A union B would be the combination of both. So these are kind of intuitive ways to look at the problem. It's not a proof because A and B don't have to just overlap in this way. There's other possibilities. And so this just gives you a feeling for what you're trying to prove, whether it's true or not. And here what I see is, the question is this football region, which is blue, contained entirely within the green region? And it is. So in my diagram, I have now sufficiently convinced myself, without a proof, that I believe it. So there's more on Venn diagrams in your book. Let me give you the page numbers for that. It is worth reading. Actually, what I recommend if you're someone who's squeezed in time, maybe I would just go to a YouTube video on Venn diagrams to understand what it is if you want a more in-depth explanation, because it's a visual thing. So they explain it. There's a Venn diagram for on page 21 in your book. So I would recommend if you're a reader and you like to read material, go ahead and read it in your book, or go on YouTube and look at a video if you're more visual and like to see it mapped out, and it gives you a pretty good explanation. Or you might just understand it from what I've drawn here. It's pretty self-explanatory. Okay, step 2. So if you're not doing induction or contradiction, like you have a set goal of a plan to do something a certain way, like I did yesterday, the second step is always to rewrite the statement as a conditional or if-then statement. So from page 18 of the book, they tell you that set containment means, the definition of set containment, they said it in words, is that everything in A intersect B must also be in A union B. That's their exact wording from page 18. That's the definition of subsets, that they've written it in words. I'm not a fan of this definition because I have nothing to get my hands into here and work with. I don't like a bunch of words. I like to have symbols and things I can manipulate. So everything is held by a variable. That's what a variable does. It is everything. So x in A intersect B means that x also should be in A union B. Every x in A intersect B must also be in A union B. So now I have an x. I can work with an x. And so that's why I do that. I tend to be a variable person, so I start to assign variables to things quickly. I've got a friend who worked with me at West Point here 20 years back. He's a geometrical person. He starts drawing things out and starting things about geometry. So everybody's got their thing. So if I want to write that as a conditional statement, the way I write that is, if I take any x in A intersect B, then that x must also belong to A union B. So now I've rewritten this as a conditional statement. So this is going to take some practice. As I mentioned in class, this is something that you just get used to, and you have to be comfortable with the idea that you're going to be uncomfortable when for some time because you're not used to it yet. So I'm only going to give you comfort in the conclusion that everybody does get on board after a while and makes it. So it's a period of time where you're just uncomfortable because you haven't seen it before and you're just getting used to it. All right, so I copied and pasted that statement. If x belongs to A intersect B, then x must belong to A union B. This is the standard operating procedure for showing one set is inside another set. You let X be an element in the first set, and then show X must be an element in the second set. So we're going to do that more often, so you'll see it again. So the next step is to identify your, what I call the no. And I didn't name it that. Students in the past named it this, so this is the no. If it's annoying to hear about what my students in the past do or said, you will be my students in the past next term, and I will say, oh, my students from last term said this. So I always draw in from whatever my past students have said. So write down the hypothesis and no. How do you extract that? It's anything after the word if and before the word then. So you just pluck that out. That's your no. That's your hypothesis. So what I know is that X belongs to A intersect B. The next step is to write down precisely what this means. In your book, that's where you go to your book. What does it mean for X to be inside A intersect B? From your book, it's precisely written out on page 21, it says X belongs to A intersect B means that X belongs to A and X belongs to B. All right, so I have that. Now I have stuff with symbols in it, and I have a particular meaning. I've floofed it out. I know what this is. I call that a nugget. It's a puzzle piece. I'm allowed to take that and use it to show what I need to show. So I'm going to pull that aside and box it off. So as you're scribbling down notes, box things off that seem like they might be important and usable. All right. Now, write down your conclusion. That's your show. Everything after the word then is your show. X must also belong to A union B. So I've dissected that out, and I'm going to write down what this means. I have to go to the book. The definition of union is very similar to the definition of intersection. There's only one word that's different, and that's or. It was very interesting asking definitions on tests. Like if someone messed up this definition and put and, do they get partial credit? This is why I don't ask definitions anymore. The definition must always be precise and perfect. And so or is a huge difference from and. That means X could be in this one or this one. That's where I'm supposed to end up. This is my last line of my proof. Therefore, X is in A or X is in B. So that should be my last line. It tells you where you're going to. Okay, so step 7, start with the nuggets and try logically to end up at the conclusion. Now, this is the part where students kind of focus on when they're first writing proof. They just want to get to step 7 and they want to bypass steps 1 through 6. Slow down, be patient, write out those steps 1 through 6. Right now, I'm going to make you. Eventually, you will just do it on your own because it should be ingrained. That's what you're supposed to do. So here's my proof. I start out with my no. Let X be an A intersect B. Write down what it means. I just copied and pasted that nugget. Copy paste is very nice. Copied and pasted it. That's what it means. What X belongs to A, I'm just writing the next statement down. Then that means X belongs to A or B by default, which means I've arrived at what I'm supposed to end up at. So what you're really supposed to say is, so by definition of union, X belongs to A union B, and therefore write down the conclusion. A intersect B is contained in A union B, and this completes a proof. The book has also proved this theorem. It's on page 22. Dr. Williams is also going to prove some things for you so you can see our different styles. I tend to put a lot of arrows and box things off so that my reader can see things. I told you I'm more flamboyant of a proof writer. The book is trying to save ink, so they're going to be terse. So you're going to see terse versions where the expectation is that you fill in gaps. We'll see what kind of style Dr. Williams has. We also think that it'd be valuable for you to see some proofs from people in class in our department so that you can see the different styles, but we can pick out what everyone's doing that's very similar so that you can really identify how to write a proof, what are the important pieces that you have to have, and then you will put in your own style. I think it's part of our personalities. Okay, proof number 2, done.